Hello my dear students. Today we are going to discuss haloalkanes and haloarenes chapter. In this, sir, what is the haloalkane first? Then classification of haloalkanes we have to discuss. Sir, first of all, what is haloalkanes? Haloalkanes means what? Sir, in the alkanes, one of the hydrogen atom if you remove and add halogen, then we call it is haloalkane. Sir, haloalkanes are alkane derivatives from the alkanes. So just to take it as alkane can be converted into haloalkane by the removal of hydrogen atom and addition of halogen atom. Sir, if you observe in this, sir, one of the example we are taking, that is methane molecule. We know that methane molecule carbon surrounded by 4 hydrogen atoms. If you remove one of the hydrogen atom from it, if you add halogen, then we can get halomethane. So these are the haloalkanes generally. So then what is the classification of haloalkanes? Haloalkanes, how many types are there? That we have to discuss. That what we are calling haloalkanes classification. Classification we are taking. In this classification, sir, first classification based on number of halogen atoms. Based on number of halogen atoms. So in that first one, monohalo compounds. Remember, monohalo compounds that contains only one halogen atom. Yes, one halogen is present in it. Sir, which are the examples for this? Sir, alkyl halides example. Alkyl halides are examples. Sir, what are the alkyl halides? Sir, if you take methyl chloride or methyl bromide or ethyl chloride, so these all are alkyl halides. If you observe in this, only one halogen atom is there. So that is the reason these are monohalo compounds. Okay, then second classification if you observe, in that second one, monohalo compounds are first one. Second one is dihalo compounds. What are the dihalo compounds? We know that in the name itself it is there. So 2 halogen atoms are there. So how many halogen atoms are there? 2 halogen atoms. 2 halogen atoms are present. Yes. So look at, for example, these dihalo compounds are, again we can divide into 2 types. So one is vicinal dihalides. Sir, vicinal dihalides means what? 2 halogen atoms are attached to adjacent carbon atoms. How? CH2 bond CH2 is there like this. Then halogen is attached there. Even halogen is attached there. So 2 halogen atoms are attached adjacent carbon atoms. Right? Sir, one more example if you take, then CH2 bond CH2. Then in case if you take chlorine, adjacent position. Then one more example, if you observe CH3 bond CH bond, then CH2. Sir, here bromine then bromine is attached there, then 1 comma 2 dibromo propane we call, then CH3 bond, CH bond, CH bond, CH3, then bromine is attached like this, then 2 comma 3 dibromo butane we call. So all these are vicinal dihalides. Sir, if you observe all these compounds, halogen atoms are attached adjacent carbon atoms. That you have to observe. Then second one is there, gem dihalides. Two halogen atoms are attached to one carbon atom, attached to only one carbon. So how it is? If you observe, CH3 bond CH, chlorine like this. Or one more example, CH3 bond CH, then CH3. So for the middle carbon, 2 halogen atoms are attached like this. Such type of compounds we are calling gem dihalides. So vicinal dihalides and gem dihalides, both are dihalo compounds. So next, trihalo compounds if you take. Trihalo compounds. In the name itself it is there, 3 halogen atoms are present in the compound. That we are calling trihalo compounds. Trihalo compounds. Trihalo compounds. How many halogen atoms are present in it? 3 halogen atoms are present in it. 3 halogens are present. 3 halogens are present in it. Sir, for example, if you take CHX3, such type of compounds. Example, in case if you take CHCl3, we call it is chloroform. CHBr3, bromoform. CHI3, iodoform. So all these are trihalo compounds. So that is third one. Next, fourth one if you take tetrahalo compounds. Sir, we know that tetrahalo compounds nothing but what? Sir, 4 halogen atoms are present in it. Sir, best example for the tetrahalo compounds, CCl4, carbon tetrachloride. It is used as a solvent generally. Carbon tetrachloride. It is one of the compound like this. Sir, in case if you take CH2 bond CH bond CH, sir, here chlorine atom, even here chlorine atom, even here chlorine atom. Even this is also tetrahalo compounds because 4 halogen atoms are present. So this is the classification based on number of halogen atoms in the given compound. In case only 1 halogen atom is there, monohalo compounds. 2 halogen atoms are there, dihalo compounds. 3 halogen atoms are there, trihalo compounds. 4 halogen atoms are there, tetrahalo compounds. Next classification based on sp3 hybridized carbon atom attached to the halogen. What is the next classification? Based on sp3 hybridized carbon attached to the halogen. So look at second classification. It is based on sp3 hybridized carbon attached to halogen. So how it is attaching? Observe it. So first one in this alkyl halides. Alkyl halides. Yes, of course, alkyl halides. CH3, CH2, Cl. CH3, CH bond CH3, Cl. Then one more CH3, CH3, then CH3, Cl. All these three compounds you can observe, all are alkyl halides. Halogen atom is directly attached to the sp3 hybridized carbon. Right or not? Yes. So this is sp3 hybridized. This is sp3 hybridized. Even this is also sp3 hybridized. Halogen atom is attached to the sp3 hybridized. But three compounds are different. So this is primary alkyl halide. Why we are calling primary alkyl halide? Halogen atom is attached to primary carbon. That is why we are calling as a primary alkyl halide. Next one, secondary alkyl halide. Secondary alkyl halide. Next one, tertiary alkyl halide. Tertiary alkyl halide. So like this. So tertiary carbon this is, so tertiary alkyl halide. Secondary carbon this is, how can you say the secondary carbon? Two carbons are attached to a carbon, or two alkyl groups are attached to a carbon, then we call it as secondary. One alkyl group is attached to a carbon, then primary. Three alkyl groups are attached to a carbon, then we call it as tertiary. So this is first. Next one is there, that is allylic halo compound. What is allylic halo compound? Halogen atom directly attached to halogen atom attached to sp3 hybridized carbon. sp3 hybridized carbon, sp3 hybridized carbon, which is directly attached to, carbon-carbon double bond. This is we are calling allylic halo compound. Halogen atom is attached to the sp3 hybridized carbon. So look at one of the example here. Carbon is there. Just assume it is sp3 hybridized. Once if it is attached to the halogen, this carbon, when it is attached directly to the carbon-carbon double bond, then we call it is allylic halo compound. Allylic halo compound. So one more example, look at CH2 double bond CH bond CH2 bond Cl. This is also allylic halo compound. So if you take this compound, here halogen atom is there. Even this is also allylic halo compound. So how can you say it is allylic halo compound? So halogen atom attached to sp3 hybridized carbon. sp3 hybridized carbon directly attached to the carbon-carbon double bond. That's it. That is allylic halo compound. Clear all of you? Right. Next one, benzylic halo compounds. Benzylic halo compounds. What is the benzylic halo compound? What does it mean, benzylic halo compounds? Sir, according to the definition, halogen atom attached to sp3 hybridized carbon, yes, sp3 hybridized carbon, which is directly attached to, benzene ring. Such type of compounds we are calling benzylic halo compounds. Clear? So look at, so carbon is there. Carbon is attached to the halogen, right? Yes, carbon is attached to the halogen. This is directly attached to the benzene ring. Such type of compounds we are calling then benzylic halo compounds. Clear? Yes. So benzene is there, right? Benzene, then attached to CH2, then Cl. Yes, benzyl chloride. Then benzene attached, then CH3 is there here, then CH2 is there, then bromine is there, like this. Even it is also benzylic halo compound, because halogen atom is attached to the sp3 hybridized carbon, which is directly attached to the benzene ring. That's it. So these are benzylic halo compounds. This is the second classification. If you see the third classification, that is based on sp2 hybridized carbon attached to the halogen. sp2 hybridized carbon attached to the halogen. It is third classification. sp2 hybridized carbon attached to the halogen. Third classification is what? sp2 based on sp2 hybridized carbon attached to halogen, that is. Yes, these are two types. A vinyl halo compound. What is the vinyl halo compound? Halogen atom directly attached to halogen atom directly attached to carbon double bond, then we call it as vinyl. For example, if you observe CH2 double bond CH bond Cl, what we call vinyl chloride. Then CH2 double bond CH bond Br, vinyl bromide. Then cyclic ring like this is there. In case if it is directly attached to the carbon double bond like this, then even it is also vinylic halo compounds. What I told according to the definition, halogen atom directly attached to the carbon double bond, then we call it as vinyl. Even this is also vinyl. So next, aryl halo compounds. Aryl halo compounds. What are the aryl halo compounds? Halogen atom directly attached to aromatic ring, that is benzene ring. Halogen atom directly attached to benzene ring, directly attached to benzene ring. So that is aryl halo compounds. So for example, for the aryl halo compounds, benzene is there like this, directly attached to the chlorine, then we call it is chlorobenzene. Chlorobenzene is aryl halo compound. Then bromobenzene. Then in case benzene already having CH3 like this, then when it is attached to the chlorine, yes, of course it is aryl halo compound. How can you say aryl halo compound? Halogen atom directly attached to the benzene ring, then we call it as aryl halo compounds. Right? Next, sir, benzene ring is there. So this is attached to the CH2, then attached to the chlorine, then what we call It is not aryl halo compound. Then what? Benzyl halo compound. Why? Because halogen atom is attached to the sp3 hybridized carbon, which is directly attached to the benzene ring, that we call it is benzylic halo compound. Benzylic halo compound. Clear enough? Yes. So this is benzylic halo compound. So this is the classification. So three types of classifications we are discussing. One is based on number of halogen atoms. Number two, based on sp3 hybridized carbon attached to the halogen. Number three, based on sp2 hybridized carbon attached to the halogen. Now, which type of questions they are asking based on these compounds in the NEET examination? Mainly in the NEET examination, which type of questions they are asking? Look at one of the question I will give. Which of the following compound? Which of the following compound? Allylic halo compound. Allylic halo compound. That is the question. Sir, option A, they are given like this: CH3 bond CH2 bond Cl. Option B, CH3 bond CH2 CH3 CH3 then Cl. Then option C, CH2 double bond CH bond CH2 Cl. Then option D, nota. Nota means what? None of the above. Sir, if you observe on this, then which is correct? C is correct. How can you say C is correct? They are asking allylic halo compound. Allylic halo compound, according to the definition, halogen atom which is directly attached to the halogen atom attached to the sp3 hybridized carbon, which is directly attached to the carbon-carbon double bond. Understand? Sir, some members they have doubt. Sir, how can you say it is sp3, sp2, sp hybridized carbon? Sir, remember always, a carbon which is surrounded by only single bonds, then we call it is sp3 hybridized carbon. A carbon when it is attached any side, then double bond is present, any side, any one side, double bond is present, then we call it is sp2. Sir, a carbon both sides double bonds are there, then sp. A carbon one side triple bond, one side single bond is there, then sp. Clear all of you? So this is, you have to identify the hybridization. Based on hybridization, we can say that. Clear? Yes. Next, we have to discuss the nature of CX bond. Nature of CX bond. Nature of CX bond we have to discuss. So it is very important. Nature of CX bond. Nature of CX bond. Sir, C and X. Sir, C carbon. Electronegativity, carbon electronegativity value, that is 2.5. Sir, halogens, if you take halogen, either fluorine or chlorine or bromine or iodine will be there. Sir, fluorine, if you take fluorine electronegativity value, we know that it is the highest in the periodic table. So that is 4. Then chlorine, if you take 3.16. Then bromine, if you take 2.96. Then iodine, if you take, that is 2.66. If you observe all these electronegativity values, when comparative to carbon electronegativity value, so these all are more electronegative. More electronegative. Yes, more electronegative. When electronegativity difference is there in between the carbon and halogen, definitely that bond is polar in nature. So, you can say one of the point, that is CX bond is polar. Why polar? Due to electronegativity difference between carbon atom and halogen atom. So, which is the highly polar? Where more difference is there in between the carbon and halogen, there it is highly polar. So, we know, we can say that 2.5 and 4, so the more difference is there when compared to these two. So, CF bond is highly polar than that of CCl bond, then that of CBr bond, then CI bond. So, this is the order of polar nature of CX bond. Okay, polar nature we are observed. Then bond length of CX bond length we have to discuss. We know that size of halogen atom top to bottom increases from fluorine to iodine. Size of atom increases, bond length also increases. So that you have to note, size of halogen atom increases, bond length also increases. This is. So next, if you observe the bond length order, so Ci is a more bond length than that of CCl, than that of CBr, than that of CCl, than CF. Clear? This is the order for bond length. Last, third one, dipole moment of CX bond. This is very, very, very important, dipole moment of CX. Why? What is the reason? Why it is more important? Due to the above two factors, one is polar factor, one more bond length factor. So now, both factors, in case if you take polar nature, if you take, sir, CF bond is highly polar than that of CCl, than that of CBr, than that of CI. If you take bond length, CI is more bond length than that of CBr, than that of CCl, than that of CF. Yes, this is the bond length order. So dipole moment, remember that dipole moment is equals to, sir, Q into D, nothing but magnitude of charge into distance between the two nucleus. So based on this dipole moment, here exceptional cases are there. Dipole moment in CCl is greater than that of CF because the distance is greater, distance is small in CF than that of Cl. Then next, sir, as usual, CBr, then Ci. So this is exception case. Here in between CCl and CF you have to observe, that is dipole moment is greater in the CCl, then CF is less dipole moment than that of CCl. Clear, all of you? So these 3 points you have to remember. One is electronegativity difference, due to the electronegativity difference, polar in nature. Second one, size of the halogen atom increases, bond length increases. Then third one, exception case, that is CCl is greater greater dipole moment than that of CF bond. Yes. Thank you, students. Next class we have to discuss about the preparation of haloalkanes.